In this tutorial, we're going to look at some of the methods of making a test bench. And the term test bench just means that you take a breadboard and you make an environment, a reusable circuit that can adapt to a lot of different experimentations. And I've just added a few things here, not too many, a few LEDs. I've got a potentiometer. You can set it up with a lot of different things, switches, etc. But the idea here is that these LEDs, and I could add many of them, they would be set up so that, okay, right now they're powered and then they're not grounded, but if a black wire went from that resistor to the ground rail on the breadboard, then the power could be used from different sources to test to see if an LED lights up. So that's one idea of a test bench. The other one is the potentiometer. You can have a potentiometer on a breadboard and you can do some programming and test whatever your application is. It could be sound, so that you're turning up and down the volume when you move the potentiometer, or it could be color channels, whatever. You can test it with the potentiometer, and then you can take the potentiometer out, and you might want to use a different sensor that has the same type of circuit. And so you can see that the potentiometer here, we have a power line running here, 5 volts of power, and then we have a ground line running here, and then that yellow wire is running over to a 10k ohm resistor, and then the 10k ohm resistor is plugged into the Arduino in analog pin 0, A0. And then there's a program which is on GitHub, which you're going to experiment with, and when you get that program going in the serial monitor, it will output the minimum and the maximum numbers from the potentiometer, because remember that the potentiometer has an analog range, a minimum number and a maximum number, and the potentiometer is 0 to 1023, which everybody knows off by heart now. The other thing here that I'll show you, right now I'm demonstrating it with 5 volts of power and ground coming from the Arduino, and I'll show you a different way to do that in a second. So let's have a look at the test bench now. I changed a few things, and I'm going to introduce a couple of new components for you. So you can see that the LED is lit up here, just as an example, because I've got power running down this side of the breadboard, and I've got ground running down this side of the breadboard. And so because I don't have a switch on it, if I pull the power wire out, it's just going to stop. So this is an example of just having pre-made LEDs with resistors in your breadboard to use for different things. Okay, so the next thing I want to have a look at is the power source. So here's the power. We've got a 12-volt wall plug, and you have one in your kit. So we plugged it into the wall, so it's taking 12 volts of alternating current, and it's converting it into 12 volts of direct current. Or sorry, it's converting whatever is in the wall, 120 volts AC, into 12 volts DC. So that means that now we've got 12 volts running through this thing called a barrel jack. There's the barrel jack. And you have one in your kit, and you probably don't know what it is. And what it does is it takes the wall power plug, which is a jack, you plug it in, and it has 12 volts of power running on that plus side and ground on the minus side, and then it plugs straight into the breadboard, like that. And then the thing here is a voltage regulator. And you have them in your kits. So this takes 12 volts of direct current, turns it into 3.3 volts of current, right? So it regulates a current from a high voltage down to a low voltage. So if we look at the breadboard, I've got 12 volts of power coming in this side of the board, and then I jump a wire over to the regulator, and in your worksheets for the Project 1 course material, there is an explanation of how a voltage regulator works. So 12 volts goes into one pin of the voltage regulator. The middle pin, it has a ground, and then the output of 3.3 volts comes over here. So this wire is sending 3.3 volts of power over to the side. And so when we power up an LED, it lights up because 3.3 volts of power is a lot of power for an LED. So we now have a voltage regulator. We can plug the breadboard into a 12 volt wall plug using the barrel jack, have 3.3 volts of power running down here and 12 volts of power running down here. Now you have to be really careful because 12 volts of power on one side and 3 volts of power on the other side, you have to be sure that your components that take 3 volts of power are plugged into the side. Now I have a program on the Arduino that has a blink program. It just makes it blink. So this is a case of I want to test whether my program works. So the blink program, it goes from pin 9 as an output pin on the Arduino and a little program that makes the voltage go on and off. So I can see, hey, my LED is blinking. I've tested my program. So that's an example of using a test bench. So there's many ways to make a test bench. This method is good because you're plugging it into the wall and you can just unplug the whole thing like this, okay? And the Arduino could also be powered from the 12 volt plug if you wanted to. I just have it plugged in here because I just downloaded a program onto it, but it could be powered separately so that the whole thing, you know, you don't have to power the breadboard from the Arduino. It just gives you more options. Okay, so that's an example of a test bench, but you can do all kinds of things with it. So for example, if you wanted to have your test bench going and you don't want to use an Arduino, you want to work with a Flora. You could jump your 3.3 volts of power and your ground into the Flora, and you could have it plugged into your computer with a USB mini, and then you could program the Flora just as you do the Uno, and you could test a wearable project using this thing. Okay, so that's what a test bench is. Another thing that's good about a test bench, you can swap out different sensors from this one analog sensor. In fact, it's a really good practice to start any analog sensor development you're going to be doing. You can start it on a test bench with a potentiometer, which is a really stable analog sensor, and then you can swap it out for another one, because any sensor that takes the same setup, which is power and ground and a 10k ohm resistor going into the analog input, you can just swap out another resistor if you want. In this case, if you were going to be working with your DIY resistors, you could just swap it out. So to test one of your DIY sensors, sorry, I think I said resistors before, DIY sensors. If you're experimenting with different shapes and patterns, then you're going to want to test them really quickly, and then all you have to do is get the alligator clips. Get one on the power pin. I just put some header pins in there. There's multiple ways that you can get the electricity in and out. This is just a quick way that I'm using to demo. Okay, so that's all you need to do to test that sensor, because it's analog and it's the same, it requires the same kind of wiring and the same size resistor, the 10k ohm, and then you can try all kinds of different things. And you can read the serial monitor in Arduino to see what kind of range of minimum to maximum numbers that your sensor is outputting. So that's one thing that makes a test bench it makes it very easy for you to try a lot of different things with the test bench. And also keep in mind when you're making your test bench, keep the wires really flat to the breadboard. If you start ending up with wires that are coming up big all over the place, you're going to end up with a plate of spaghetti on your breadboard in no time. And then it gets really confusing. It's hard to work with. So if you were leaving your test bench on your desk, for example, and your cat walks by, if the wires are really tight to the breadboard, your cat could walk on it, wouldn't do it any damage. With a lot of wires that are coming off the breadboard. And see these ones, this is the exception because they're unplugging them into different things. So there's a reason you'd want to plug things in and out. But these ones are stationary. They're going to stay here for quite a while. Another thing to keep in mind, the way that I jump the power over here, this might be a bit tricky because you might be looking at it saying, hey, I don't see a ground wire. So the ground wire coming down at the end here jumps from this rail over to this rail. And then the power coming out of the voltage regulator jumps into the power rail along here. And then another thing to keep in mind when you work with a voltage regulator, 12 volts of power are coming into the circuit here. 3 volts of power are running down the rail here. So what's happening to the extra 9 volts of power? Where do they go? Well, they get transformed into heat. So if you look at that aluminum piece on the voltage regulator, over time that's going to heat up. So the 9 volts of power gets dissipated in heat. So be careful that if you had this thing on for an hour, this thing might heat up quite a bit. And then, you might, I don't think you'd have a serious burn, but you don't want to get burned at all. So keep that in mind when you work with a voltage regulator.